Welcome, dear friends. Today we are going to see an introduction to mixing. So the objective of this topic is that upon completion, the students will be able to explain what is the objective applications and factors that affect mixing. Students will be able to explain difference between solid and liquid mixing. Also, they will learn about a mechanism of solid mixing, liquid mixing, and semi-solid mixing, and they will learn the construction working principle, uses, merits and demerits of double cone blender, twin shell blender, ribbon blender, sigma blender, planetary mixer, propellers, turbines, paddles, and silvers and emulsifier. So mixing is an operation in which two or more components in a separate or roughly mixed conditions are treated so that each particle lies as nearly as possible in contact with another particle or with the particle of each of the other ingredient. So mixing is defined as a process that tends to result in a randomization of dissimilar particles within a system. So mix is to put together in one mass or assemblage with more or less thorough diffusion of the constituent elements among one another. And blending means to mix smoothly and it becomes inseparable thoroughly. So some of the mixing operations in the dispensing practice are trituration, tumbling, geometric dilution, etc. So a major complication in the intimate mixing of particles is the segregation of particulate solids that result from gravitational effect on the agitated bed. Now suppose this is a bed which is being agitated. So if you mix them, the solid particles, they get mixed with one another, and but a major problem is that there occurs segregation. So segregation means what? Now as you can see here, if you mix this powder blend, the smaller particles, they fall in the lower region, okay, in between the gaps of the larger particles. So this size separation, depending on the size, okay, so this particle separation depending on the size is a major drawback, and that is called as segregation. So in segregation, what happens? The smaller particles, they fall down or they occupy the lower space, and the larger particles, they occupy the upper space. Okay, so segregation is a major problem in case of pharmaceutical products, because most of the pharmaceutical products, the filling process or the operation process, it occurs by volumetric filling. Okay, so it is a major concern. So the diverse characteristics of the particles, such as size, shape, volume, surface area, density, porosity, flow, and charge, it contribute to the solid mixing. So so in solids, there are two types of solids are there. The first is cohesive materials such as wet clay, and it is characterized by the resistance to flow through the openings of the containers. And non-cohesive material, which includes grain, dry sand, and plastic chips, they readily flow out of a bean. The difference between solid and liquid mixing is there occurs flow currents, which is responsible for mixing in liquid mixing, and in solid mixing there is no flow current. In liquid mixing, homogeneous liquid phase is observed, whereas in case of solid mixing, product often consists of two or more easily identifiable phases. In liquid mixing, small sample size is sufficient to study degree of mixing, whereas in case of solid sample, large sample size is required. In case of liquid mixing, mixing requires low power. In case of solid mixing, mixing requires high power. So that was the difference. Now, what are the applications of mixing? Wet mixing, it is carried out in preparation of granules for tablets and capsules. Dry mixing, it includes direct compression, as in case of tablets. So when we prepare a tablet by direct compression method, in that case, we need to go for solid mixing. The dry blending mm, is carried out for the preparation of capsules or dry powders, insufflations, dry syrups. So the production of it also includes it is also involved in production of pellets. So the objective of mixing is to ensure that there is uniformity of the composition between the mixed ingredients, which may be determined by taking samples from the bulk material and analyzing them, which should represent overall composition of the mixture. Also, it is carried out to initiate or to enhance the physical or chemical reactions. For example, the chemical reactions which are the physical reaction important is diffusion, dissolution, etc. So generally mixing is carried out to obtain following type of products, that is when two or more than two miscible liquids are mixed together. This results into a solution and this is known as true solution. So when two immiscible liquids are mixed in the presence of an emulsifying agent, at that time we get an emulsion. When a solid is dissolved in a vehicle, we get a solution. But when an insoluble solid is mixed with the vehicle, at that time it creates a suspension. So when a solid or a liquid is mixed with the semi-solid base, we get an ointment or a suppository. When two or more than two solid substances they are mixed together, then we get a powder, which when filled into a capsule shell is known as capsule, and when it is compressed under heavy pressure it will result into tablet. So let us see the factors which affect mixing of solids. It is the density of the particle, but it is of minor importance. Then demixing is accelerated when the density of the smaller particle is higher or when the mixing process is stopped abruptly. So this is due to the fact that dense material it always moves downwards and it will settle at the bottom. So that is segregation. Then next it depends on the proportion of the materials. So when two powders they are mixed in same proportion, then best results of mixing are obtained. But if there is a large difference in the proportion of two powders, then mixing is always done in ascending order of their weights. So also it depends on particle charge. Some particles they exert attractive forces due to electrostatic charges on them. So this results into separation and segregation. It also depends on the nature of the product. Rough surface of one of the components does not induce proper mixing. The reason for this is that the active substance it may into the pores of the other ingredient. A substance that can absorb on the surface can decrease aggregation. For example, addition of colloidal silica to a strongly aggregating zinc oxide can make it a fine dusting powder which can be easily mixed. It also depends on particle size. So variation in particle size leads to separation as the small particles they will move downward through the spaces between the bigger particles. So as the particle size increases, flow property also increases due to the influence of gravitational force on the size. So it is easier to mix two powders having approximately the same particle size. It is also affected by particle shape. For uniform mixing, the particle it should have spherical shape. The irregular shapes can become interlocked and there are less chances of separation of particles once these are mixed together. So let us see the types of mixtures. The first type is positive mixture. It is formed when two or more gases or miscible liquids they are irreversibly mixed together by diffusion process. Here no energy is required, um, uh, provided the time allowed for the solution to mix is sufficient. Then there is negative mixture. It is formed when insoluble solids are mixed with a vehicle to form a suspension or when two immiscible liquids are mixed to form an emulsion. They have high tendency to separate out. They are not continuously being stirred. And last type is the natural mixtures. It has got stable behavior. The components they do not have tendency to mix spontaneously, but once they are mixed, they do not separate out easily. So type of mixing it also depends on the physical state of the material. So depending on the physical state, there are three types of mixing. One is solid mixing, other is liquid mixing, and the last is semi-solid mixing. We will see all these types in detail in the next lectures. So, so this was all about the introduction to mixing. Thank you for watching.